lab is installing a colossal automated fiber placement. We'll shorten that to AFP machine to make Neutron the largest carbon composite rocket yet. 99 tons, 39 feet tall. I mean, this is a robotic behemoth, custom built by Washington-based Electroimpact and designed to automate production for Rocket Lab's massive rocket parts. Sounds like the AFP machine is going to build Neutron's 91-foot interstage, the 7-meter diameter first stage, the 5-meter diameter second stage tank, really covering the entire rocket length with automated precision. This AFP machine is capable of laying 328 feet of carbon fiber per minute. Wow. The AFP, yeah, that's crazy. Equipped with real-time inspection tech, instantly detecting material flaws, the setup is projected to cut Neutron's production time by a whopping 150,000 hours, which is a lot of hours and equally a lot of money, which enables Rocket Lab to meet ambitious launch schedules.
Yeah, this AFP thing is crazy. 150,000 hour reduction in construction. 300 and whatever feet of carbon laying per minute. Really, really crazy, I got to say. Effectively managing, because I think what it's doing, it's adjusting as it's pouring, as it's shooting this kind of carbon out there. So the backbone of this is going to be the data. It's that consumption of data to know where it's at, because it's pretty autonomous by the sounds of it. So massive data generated by that AFP machine, real-time inspection system to optimize your production and maintain quality every step of the way. That is going to be the number one challenge for this beast.
I think, okay, first off, this whole thing is fascinating. We're looking at almost a football field being laid per minute. I mean, that is fascinating to think of, right? When you're doing something with all of this speed, this advancement, quality is going to be a concern. And it's my number one concern for the rocket production portion of this, because you have to have a machine that checks the quality. And the machine here, it can actually check itself. So it's fully automated, real-time inspection system that hunts for the tiny defects throughout the laminated carbon composite and alerts the machine operator of any issues before the next layer gets laid down. So we have assurance that everything is correct and is going to meet quality standards, all happening by the machine itself.
Okay, I agree and I disagree. You're right, quality is an issue, but you need the data in the first place, and the data in the first place is going to be massive. It is going to be the big data that's coming in. So that AFP machine is going to have to churn out huge amounts of real-time inspection data. So without that as the solid core strategy, those valuable insights could get lost in, frankly, a data deluge. So that's going to lead them then to missed opportunities for process improvements. So really, the utilization of that data is going to be key to staying competitive, efficient, profitable, and making sure those rocket components are going to meet the stringent quality standards that are going to be laid out.
So I think that, well, you are correct, just not as correct as you could be. The size of the whole operation, we've already mentioned, is impressive. The speed, the scale. And I mentioned that for me, the number one for the rocket production was the quality. But I think what might even be more important here is looking at the machine's maintenance itself. When you have downtime on this machine,
you're
losing a lot of production. When it makes mistakes, you're losing a lot. So I kind of want to look at the PLM for the product that's supporting the rocket PLM, right? We have a machine that's made to help with the rocket manufacturing, but that machine, what about its maintenance, its downtime plans, its predictive maintenance? You know, what we have to do something here to make sure everything works smoothly once you put this huge investment in.
I mean, you know, solution to that whole predictive maintenance thing is an AI industrial layer over the top of that and predicting that whole maintenance thing. So that's that. If we can go back into critical thread, we can talk about SBOMs and scheduling and planning and all that kind of good stuff and disassembly of the AFP. But I think as a solution, speaking to the whole data thing, which is clearly the number one challenge, in my opinion. The critical thread infrastructure are the foundations of success here. Establishing that centralized data management platform that seamlessly integrates with the AFP machine. Then when you've got that in place, then you've got to have cross-functional teams to interpret and act on the data. So you need that collaborative platform running. Then you've got to implement your real-time analytics dashboards to monitor the production metrics, identify any trends or any anomalies that are coming in real time and instantly. And then you've got to sprinkle a little AI into this whole thing, I think. So you've got your predictive analytics. So your forecasting intelligence to tell you what's likely to be happening in the future as well. And then deploying your machine learning algorithms to continuously improve as you go forward. So a lot of AI stuff, and getting that critical thread foundation for the data for me is the solution.
So there you have it. 3 number 1 challenges.
Whatever disagreements you guys are having, keep leaning into that. I like seeing this back and forth. So keep going. And Andrew, you've got a leg up. Like it looks like Brian is without the use of one arm this week. So
no, you said leg up. You meant arm up.
That's right. I meant arm up. You got an arm up. That's right.